Hello and welcome to this video brought to you by Smart Edu Hub Mumbai. Today's topic is electrolysis of aqueous ionic compounds. Now, aqueous ionic compounds. There are two types of aqueous ionic compounds. So let me just write down aqueous ionic compounds. So there are two types of aqueous ionic compounds. One is the dilute ionic compounds, and second is the concentrated ionic compounds. Now, main difference between dilute ionic compounds and concentrated ionic compounds is that both of them contain water, obviously, so they will definitely contain the ions from water. That is, the dilute part will definitely give you two kinds of ions, H plus and OH minus. Similarly, concentrated will also give you H plus and OH minus. Similarly, ionic compounds will give their own ions. Now they will give one positive ion also and one negative ion also. That means there will be an anion given by the ionic compound and there will be a cation given by the ionic compound. Now which anion will be there, which cation will be there, that will be decided by the ionic compound that we are using. So as of now, just remember that there will be a positive and a negative ion, that is a anion and a cation donated by the ionic compound also. So in all, if you talk about just ionic compounds, so you'll have to make a list of the ions that are present. Now why am I saying you'll have to make a list? A simple reason. Because in this case, if you have cations, there are going to be two cations. If there are anions, there are going to be two anions. Similarly, for the concentrated also, there will be two cations and two anions. That means there's going to be a competition for the ions to be liberated at the electrodes. Now, because these are aqueous ionic compounds, the rules are slightly different for anions. We know there are rules to be followed by the ions. So let us understand what are the rules that are followed by the cations and the anions when it is about electrolysis of aqueous ionic compounds. Now always remember, all the cations, that is the positive ions, they always follow the reactivity series. So they are going to follow the reactivity series. So what about the anions? Anions are the negative ions. Anions, say we are naughty. Anions are negative ions. N for negative ions, N for naughty, and N for no. So anions are naughty ions. They say no, we will not follow our series. So they say we'll make our own series. And they say our series is known by a special name. So that means actually there is no series for the anions that the anions will follow. Rather, the anions say we have a new rule. And the rules that anions will follow is majority wins. Sounds funny, but it makes sense. So the rule is majority wins. Now let us understand the electrolysis of dilute and aqueous ionic compounds by actually taking an example of some dilute ionic compound and some concentrated ionic compound. Now for example, if this would have been, for example, say this ionic compound would have been NaCl, and suppose the aqueous concentrated ionic compound also would have been NaCl. Okay, so what we can understand is we are going to talk about the electrolysis of dilute and aqueous ionic compounds. So in a way we'll be talking about electrolyzing the compounds and what will be happening as a result of electrolyzing the dilute and concentrated ionic compounds. Now suppose you have dilute NaCl on the left. So you know the cations the positive ions from the water will be H plus, and the anion from the water will be OH minus. Similarly, the ionic salt will be giving the cation which is Na plus, and it will be giving the anion which is Cl minus. So the same set of cations and anions will be present for the concentrated solution also. So simply we need to copy this down. Now I am giving you a comparison. The reason is it will help you to understand better. So let us go to the rules. Cations always follow the reactivity series. Reactivity series says whichever ion is down will be liberated first. So we have a competition between two cations. So these are the two cations. There's a competition. We need to decide who will be liberated at the cathode. Okay. So now compared to H plus and Na plus, H plus is lower down. Hydrogen over here is lower down compared to sodium on the top. So therefore hydrogen will be liberated. So at the cathode, what will be my half equation? 2H plus 2E minus gives you H2. That will be at the cathode. And at the anode, what will be the ion that will be liberated? First of all, anode is a positive electrode. It is going to attract the negative ions. So there will be two anions that will be attracted. Now the rule for the anions is majority wins. That means whichever negative ion is in excess, that will be liberated. Now solution is a dilute solution. That means OH ions are in excess. So at the anode, 4OH minus 4E minus gives you 2H2O plus O2. So O2 gas will be liberated. This is what will happen at the anode. Also, let us now find out the products of electrolyzing concentrated ionic compounds. Now again, as you can see, there are two cations here, and we need to decide which cation is going to be liberated. So at the cathode, you know that the cations always follow the reactivity series. So just now we saw that between H plus and Na plus, H plus is lower down. So at the cathode you will have 2H plus 2E minus gives you H2 gas. So H2 gas will be liberated. Usually you need to write the states. I'm not writing it here, but ideally for every equation please write down the states. Also at the anode, what's going to happen? We have just decided that the anode will attract the anions, and anions are negative ions. Negative ions say we have a new rule, and the rule is majority wins. So therefore concentrated solution have more of Cl minus ions. So at the anode we will have 2Cl minus 2E minus gives you Cl2. Now as you can see, at the cathode and the anode we have hydrogen and chlorine being liberated. That means for concentrated NaCl I'm talking about. So if you cancel the H plus ions and the Cl minus ions, what happens to the electrolyte? The leftover electrolyte is nothing but NaOH. So from being concentrated ionic compound, the electrolyte changes to being sodium hydroxide. So this is the change to the electrolyte. And in this case, in the case of dilute ionic compounds, we have hydrogen ions being liberated to form hydrogen gas. We have oxygen gas being liberated. So basically water is getting decreased. The quantity of water is getting decreased. So from being dilute ionic compound, after electrolysis, what is left is more of NaCl, and therefore the compound becomes concentrated ionic compound of NaCl. So whenever you electrolyze dilute ionic compounds, you end up with getting concentrated solutions. And in the case of concentrated NaCl specifically, H plus and Cl minus will be lost. So what will be left is Na plus and OH minus, that is sodium hydroxide, will be formed. So this, what I have done, what have I done? I've actually created a new set of rule, my own rule you may say, that majority wins is the rule for the anions. So, and the cations always follow the reactivity series. So you keep this in mind and you will be able to find the products of electrolysis of any given aqueous ionic compound. Okay, so that's all in this video for electrolysis of aqueous ionic compounds. I hope you liked watching my video. Please do subscribe to my channel if you like. Thank you.